the same. Your certificate of participation shall be auto-generated, and delivered into your inbox in a few minutes. So, dear participants, kindly ensure, please share your, please ensure that your chat window is working. It appears as a bubble icon on your screen, and you can click on the same, write in your affiliation and details to ensure that it is working. In a few minutes from now, we shall be beginning with today's session. Dear participants, for all those participants who have joined us just now, I welcome you all once again to today's webinar on AI-based transformer technologies. Our expert for today's webinar, Mr. Ganesh Sahai sir, Global CTO, Nagaro, is already there with us. And within a few minutes, we are going to start with today's session. Meanwhile, I request all the participants to kindly ensure that whichever devices they are connected with us through for today's webinar, they are able to access the chat window on the same. This webinar is also being live streamed on our official YouTube channel, BBI Cam New Delhi. But the live streaming, dear participants, is only for knowledge dissemination purposes. So kindly ensure, in case any of your friends, your colleagues plan to join the webinar, but through our YouTube channel, kindly request them to join the webinar directly through the WebEx room, because the feedback link for the certificate of participation shall only be shared with the participants who join the WebEx room directly. So I request all the participants, kindly ensure that all of you join through the WebEx room. Until the time you do not receive your certificate of participation after submitting your feedback form, kindly do not leave the WebEx room. We shall be there to help you out with your certificate of participation. I once again welcome all dear participants who have joined us today for this webinar on AI-based transformer technologies. In our IEEE Technical Series webinar, dear participants, today this is our 94th webinar and we are heading towards 100th webinar. This is just an effort from our side for widespread knowledge dissemination among all the technical community, and we hope we are succeeding in the same. Our expert for today's session, Ganesh Sahai sir, shall be enlightening us on AI-based transformer technologies. And if I say AI, so AI is no longer a complex term which was thought to be only part of the higher academic scientists today. Today, AI is something that is everywhere and around us, anytime, anywhere. So what are these AI-based transformer technologies? How are they affecting our lives? What are the challenges ahead? We will all come to know from our expert for today's session, Ganesh Sahai sir. Thank you, dear participants. Thank you for sharing your details in the chat window. It is wonderful to see that participants from all across the country and all over the globe are joining us today for this fruitful session on AI-based transformer technologies. Within a while from now, we shall be beginning with this session. I welcome all the participants who have been joining us every week with all our webinars. And I welcome all those participants who have joined us today for the first time with this webinar. I hope you will like our webinars and you will continue joining us every week. We are just waiting for a few more panelists to join, and then we shall soon be beginning with today's webinar.
So Ganesh, in the meanwhile, did it work? There were a lot of useful options given by a lot of people.
Yeah, I was trying out, but doesn't look like there is a setting to share your computer audio.
Okay. Yeah, that's what Dr. Ritika was saying, that everything has been tried
We have
today.
tried everything today, but I
Alright.
think we'll have to blame WebEx for this thing. And we have already fired a complaint to them.
Good, good. Yeah, that's proactive.
Yes, sir. Because generally we do not have any such glitches.
Yeah.
Because there is some optimized video setting.
Yeah, that's what people are saying. Some of the folks are saying.
Yeah, because I am sure optimize video setting. Video settings. Let me go to optimize video setting.
Thank you for your suggestions, dear participants. And it's wonderful that you are owning this webinar along with us. That was our aim when we started with the webinar series. So thank you, all of you.
So during optimize, select the include audio option if that appears, Ganesh.
Yeah, that's, I don't know, that option is not coming anywhere.
Okay. Okay.
Just looking at that. Sharing content, layout modification, appearance, advanced settings. I think I saw it somewhere, but then it disappeared. To speaker, microphone, WebEx.
Yeah, Dr. Ritika, can we start waiting for Professor Huda to join?
You're on mute, Dr. Ritika.
Sorry, sir. Yes, sir, we are waiting for Huda sir to join in. Sir is just trying to join in.
Okay.
So just 1 or 2 minutes more, I think sir would be able to join in.
Okay. So Ganesh, the last option which typically works is maybe log out and log in.
Yeah, okay, let me try that also.
Yeah.
So dear participants, I once again welcome all of you to today's webinar on AI-based transformer technologies. And very soon, in a while, in a few seconds, I would say, we won't be delaying it any further. So we will be starting with today's webinar. Every week, dear participants, we try to bring whatever new technology, whatever new trend is there in the field. So this week, we are back with AI-based transformer technologies. And we have our expert, Mr. Ganesh Sahai, Global CTO Nagaro, who is already there with us. A number of other distinguished panelists are already there with us. And without waiting any more, Professor M.N. Huda, sir, Director Bharti Vidyapeeth has joined us. Good evening, sir.
Good evening, everyone. I'm sorry because I was held up, and then finally, when I came, this system was not allowing me to join. But finally, I've joined. Thank you so much, and I'm extremely sorry. Please start.
Yes, sir. A very pleasant evening to all distinguished panelists and participants. Bharati Vidyapeeth Institute of Computer Applications and Management, BVI CAM, in association with Computational Intelligence Society, CIS chapter of IEEE Delhi section, Computer Society chapter of IEEE Delhi section, Technology and Engineering Management Society, TEMS chapter of IEEE Delhi section, System Man and Cybernetics SMC Society chapter of IEEE Delhi section, Communication Society of IEEE Delhi section, Consultants Network Affinity Group of IEEE Delhi section, Life Member Affinity Group of IEEE Delhi section, Inter-Society Relations IRS Standing Committee of IEEE Delhi section, Industry Relations and Special Interest Group on Humanitarian Technology, Site Standing Committees of IEEE Delhi section, the Associations of Computer Society of India, CSI, Institute of Information Technology Professionals, IITP, ISTE Delhi section, and IETE Delhi Center as technical collaborators welcomes you all to the webinar on AI-based transformer technologies. It is a moment of pride and honor that we, with united hand, mark special contribution the monumental occasion of Azadi Ka Amrit Mahotsav, an initiative to celebrate 75 years of glorious independence by organizing thought-provoking sessions for our better future. This webinar is an initiative for celebration of Azadi Ka Amrit Mahotsav. According to John Fremont, there is no one thing that defines artificial intelligence. It is more like a tapestry of modern intelligent technologies knit together in a strategic fashion that can then uplift and create a knowledge base that is automated, where you can extrapolate findings from there. This saying lays the foundation of today's webinar as it showcases the importance of AI in our current daily life. One of the interesting areas of usage of technology has been how we can make machines take instructions like humans and perform various activities. For example, asking to draw a watercolor portrait of kids playing basketball along with robots during sunset with Golden Gate Bridge in the background, or asking a robot to go and fetch a glass of water from the kitchen, etc. These human conversations, when done with machines, involve a lot of technology around natural language processing. Transformer is one such technology based on deep learning models which cater to these kind of use cases. This technology has evolved a lot over the years. In recent times, technology from OpenAI, Google, Microsoft, etc., are already revolutionizing the way machines work, and in future, looks like such technologies can replace lots of human work. It looks like that in future, this kind of technology and machines would be in many ways at par with humans. Sounds super and scary at the same time. So the webinar today aims to discuss the various aspects of the transformer technologies. Before we start, I would take this opportunity to welcome amongst us our distinguished panelists for the day. We are privileged to have amongst us a galaxy of experts. I would first now welcome Mr. Saurabh Agarwal, Head of Strategy and Growth, PSU Business, TCS. During his long career of over 26 years, Sir has widely traveled and worked in multiple countries. He has received several awards in TCS for his management and leadership skills and is a certified mentor and counselor. Being passionate about mentoring young professionals on management leadership along with digital technology and its socio-cultural impact, Sir has an expertise in strategy, leadership, innovation, and coaching. He also advises young startups on designing their products along with the marketing strategy and also has his hands on academic councils and advisory boards of several engineering colleges and universities. He has been a regular mentor on Smart India hackathons organized by Ministry of Education, Government of India, and has been judged in all the editions till date. He is an active member of the Computer Society of India and was recently also elected to the National Council of All India Management Association. I welcome you today to this session, sir, and I will now request you to commence the session with the welcome address.
Thanks, Dr. Ritika. And first of all, I would like to compliment BVI CAM and Professor Hoda for such an engaging series of webinars, which has been going on for more than 2 years now, almost every week. And as Dr. Ritika mentioned, this is the 94th webinar, and I look forward to a grand celebration during 100th webinar of this series, which I hope will be a national record too. And during these 94 weeks, the topics have been quite varied across technology and non-technology and the societal impact issues, and which is so important. But I have to admit, I have a very, very limited knowledge of today's topic. So I'm here to learn and listen to our esteemed speaker. But as I said in one of the previous sessions, there have been technologies like artificial intelligence, which we have been reading as a theory subject for last 3 to 4 decades. I remember, it was one of our special topic during my engineering days in the 90s. But it is only in the last decade that we have actually seen its practical uses and the importance in our day-to-day life. Now it's everywhere, the artificial intelligence and the machine learning and the deep learning, and now what we are calling as AI-based transformer technology. As I understand, this technology is just 5 years old. The term AI-based transformer was coined around 2017. But we are already talking about it and how it is going to make an impact on us as a deep learning model. So I think we are in exciting times, and where the gestation period of a technology has improved or reduced quite a lot from decades earlier to just a few years now, when it actually becomes a reality in practice. So I look forward to listening to Mr. Ganesh Sahay and learn something new today. Thank you.
Thank you, sir. I would now request Professor M.N. Huda, sir, Director, Bharati Vidyapeeth Institute of Computer Applications and Management, BVI CAM, and Vice Chairperson, IEEE Delhi Section, to address the participants with his inspiring words.
Good evening, one and all. I once again apologize for starting the program a little late. At the outset, let me pay my gratitude to the valued speaker of today's session, Mr. Ganesh Sahay, Global Chief Technology Officer of Nagarro, who has readily agreed to deliver this very much needed technical lecture on a topic of interest to everyone, which is AI-based transformer technologies. The name AI-based, AI is a very common concept now. Almost every one of us are aware. Even Saurabh admitted that AI is known to me, but transformer technologies is a little new, so it was required to be spoken. So thank you so much for having agreed to deliver this talk. And I also take this opportunity to welcome all my friends from various professional societies. Mr. Ajay from IEEE Delhi section, and my old friend who is a great source of strength, for enabling me to organize such webinars and invite such luminaries to speak on this platform. My friend Mr. Saurabh from TCS, the former chairperson of IEEE Delhi section, Professor Subramaniam Krishnamurthy, Professor Bhatia, and all my learned friends, participants from various parts of the country and abroad, who keeps on waiting for this evening webinar, which is, this one is of under IEEE BVICAM IET evening weekly webinar series, and this is 94th of such series. Dear friends, we started this webinar in the backdrop of the COVID-19, in May 2020, and since then, with one or two exceptions on some Saturdays, we are continuing this. And this probably is one of the most sustainable webinar series, as Mr. Saurabh has acknowledged, of the country, and under the banner of IEEE and BBICAM. Dear friends, the topic which we have kept today is primarily whatever name we do keep, but primarily it is related to AI. The question before all of us are that how to ensure that machine can take instructions the way human being takes instruction. I have taught this paper close to 11, 12 years, and at that moment it was considered as a dry paper. And the paper, students used to ask, why are we studying this paper? We don't see any applications. I'm talking of around 2 decades ago. And then I used to say that someday it will be very important, so I study it, because it is not possible that machine will be left to be only at the 4th generation level. We have to move machine intelligence to the level of the 5th generation, and then of course the 6th generation. And when fuzzy started happening, we started visualizing and realizing, yes, someday will come that machines will start taking instructions. It was something like when in 1956 John McCarthy coined the concept in one of the conference in the US that machines can think. People started laughing on John McCarthy. But machine can do whatever we imagine and whatever we can provide an instruction to the machine, that one of us are witnessing that. And probably whatever gadget in whichever way we are using, somewhere or other, the machine's intelligence is exhibited. Question is now to which extent it can take instructions, to which extent it can exhibit intelligence. And I always used to say that the fundamental definition of the intelligence is if you can find similarities out of dissimilar, distinct objects, and otherwise, if you can find distinction out of a similar object, then we claim that machine is intelligent. Or otherwise, the Turing test is known to everyone. As a teacher, I'm fond of giving examples, and I used to give example in the classroom in the first lecture, what is artificial intelligence, and I used to say them that look, in a village, there used to be a Badi Amma, and Badi Amma is considered or imagined to be knowing everything. And in that village, a person from Dubai came, and the first time he brought a knife. No one in the village saw the knife. And then everyone was contemplating, this is this device, this is that device, this is that device. And finally they decided कि बाबा हमें पता नहीं है तो बड़ी अम्मा को बुला लेते हैं. बड़ी अम्मा तो दुनिया देखी है, 80 साल की है, वो इमीडिएटली बता देंगी कि यह है क्या चीज. अच्छा, बड़ी अम्मा आई, बड़ी अम्मा ने भी कभी नाइफ नहीं देखा था, उन्होंने ऐसे देखा, ऐसे देखा, ऐसे देखा, और कहा तुम सब क्या समझते ही नहीं, अरे ये आरी होती है 100, उसका बच्चा है, अभी दांत नहीं आया है. तो सबने कहा क्या ग्रेट, बड़ी अम्मा ने इंटेलिजेंस बताया. भाई हमने मान लिया बड़ी अम्मा की इंटेलिजेंस को अपने. अब यही क्वेश्चन मार्क है कि who amongst us are the domain expert, to which level we are capturing the domain expertise in the system. If the domain experts are very capable and the level of the capturing the domain expertise is very high, probably the capability of machine taking the instructions will be very high. If we are lacking in the domain expertise and we are not in a position to provide right instruction to the machine, then probably the machines will be less intelligent. But this subjectivity and this discussion will keep on happening, and not because of this that machines cannot take full instructions. We as technologists have to believe that we have to provide instructions and we have to take help of the machine, and then only probably the human intelligence, the natural intelligence, the innovation and creativity of the people will be utilized for something, some other better purposes than putting it into a routine task by the machine. So the routine task instructions will be taken by the machines and the machine will exhibit that. With that background, this topic has been kept today, and for that we have amongst us Mr. Ganesh Sahay. He will be enlightening us at which extent this AI based transformer technologies are coming in a big way, and in which way it is going to help us, and what are the possible successful use cases in the industry which is available at this moment. But that is the future, and the pervasiveness of this cannot be denied in the future. So thank you so much, my dear friends from various parts of the country and abroad, and my special thank to the learned speaker today, Mr. Ganesh, and of course my friends Mr. Ajay and Mr. Saurabh and all of you. Let's keep tuned to Bharati Vidyapit and IEEE webinar series every week. And with this note, I will take leave that stay safe, stay connected, keep learning despite disruptions all around us. And every week, Saturday evening 6 to 7:30, join our webinar. And every week we have some other webinar. There are few more webinars which have already been notified in the public domain. If you have not registered, you can register it. So with this note, कि फूलों की तरह फिर खिलेंगे हम, फूलों की तरह फिर खिलेंगे हम, और अगले सैटरडे को एक नए टॉपिक के साथ फिर मिलेंगे हम. Thank you so much. All the best to all of you. Over to you, Dr. Ritika.
Thank you, sir. I will now welcome amongst us our expert speaker, Mr. Ganesh Sahai, sir, Global CTO Nagaro with an e-booking.
It's all technology, huh? AI transformer based technology.
Yes.
No hard thing, all soft.
Ganesh Sahai, sir, is an IIT and IIM alumnus with around 25 years of industry experience. Having worked with companies like Adobe and Oracle, he is currently working as global CTO at Nagaro, which is the fastest growing software services company on the planet. He has also been an entrepreneur on multiple instances and did multiple ventures. His passion towards technology, innovation, people, and business led to setting up of great terms and release of world-class products doing successful business. His innovation streak led to filing of 11 patents. He has keen interest in the latest development in technology and business environments and keeps sharing about the same along with personal analysis with different teams and communities on a regular basis. We are honored to have you amongst us today. I welcome the great intellect to this session, and I would now request you to kindly enlighten the house.
Thank you so much. Am I audible?
Yes.
Oh, yes, sir.
All right. Thank you so much for the kind invitation, and it's a pleasure to be on this platform. Ajay was kind enough to share the invite, and I'm so delighted to be here. So, without further ado, let me jump into my presentation for the day. All right. Can you see my screen?
Oh, yes. Yes, it is visible.
Awesome. Okay. All right. So once again, welcome everybody to this session on evolution and future of AI-based transformer technologies. If you look at this picture, what do you think? This is, somebody painted it or it was machine drawn? It's very hard to kind of figure it out at the moment, right? But we'll come to this. Just kind of grasp this picture for some time. And this was one of the text which I shared in the abstract also, a watercolor portrait of kids playing basketball along with robots during sunset with Golden Gate Bridge in the background. So that is the kind of thought an artist can have. But can machines have that kind of a thought process and generate these kind of pictures or these kind of paintings, let's so say? So we'll see as we move along. Similarly, let's say robots doing household work with family members. Somebody has that thought, and whether machines can, think of the same and draw something like this. Or let's say, we have already experienced this technology, which is, for example, let's say there is some German text, right? And, we want to translate into English. And we know Google Translate does it very well. And this is, for example, a note from Roger Federer, who recently announced retirement. But what are the challenges of basically these translations when we do it through machines? It's something that we'll look into. So overall, if you look at it, what we want is, and what we are striving towards is that a machine should start to interact with us and start to serve as more like humans. That's a kind of a, end goal or kind of a vision a lot of research teams and a lot of, technology people have who are working on these kind of technologies. All right, so I'll skip this abstract. Now, if you look at, the journey of human species on the planet, starting from let's say when the dinosaurs came to an extinction, and various human species started to evolve, and ultimately, Homo sapiens, flourished, and we are, the Homo sapiens, and the other species of the human beings kind of, went away. But the Homo sapiens themselves have been evolving over the years, and right from Ice Age, Stone Age, and so on and so forth. As you can see, we have come all the way to wearing more technology on us. And if we look at the this blue thing, this is something which is related to teleportation, where it's a kind of a visualization where all the human body cells can be transported from one place to another without doing any physical travel as such. But anyways, that's a kind of a too fictional thing. So moving on, coming to the practical aspects of it and what we have experienced so far, in the industrial world, and so to say industrial revolutions, and some people term them as industry 1.0, 2.0, 3.0, and 4.0. If you look at mechanization, for example, steam power, and steam power was one of the turning points in terms of basically enabling the humans to do things without putting in more human effort, right? Whether, let's say, it was towing a locomotive, but it was more from the point of view of pumping the water from the mines where coal was used to be dug up. That was primary motive. And as you know, James Watt was quite instrumental. We have been taught this since our school days in coming up with the revolutionary changes to the steam engine. By the way, this is something which I always share in some of the innovation boot camps that I conduct, that James Watt did not invent steam engine. He basically came up with a modification where the condensation inside the steam engine was done outside of the steam engine, thus led to basically saving of the heat, right? And the steam engines became more efficient. And that was revolutionary. He patented the technology, and he had the monopoly over the steam engine market for almost 20 years. Anyways, moving on, electricity was a major turning point, and all thanks to Michael Faraday and his persistent efforts to generate electricity from magnetism. Because if you look out anything around us, if we take out electricity for a moment, uh, you know, a lot of things will come to an halt. Or let's say, for 1 month there is no electricity in the world. Imagine the scenario: no computers running, right? There is no factories running, right? So much, like it will just come to a grounding halt. Um, and that basically led to further efficiencies in doing things, and mass production started to happen. If you look at assembly line production started by Ford and then General Motors, and so much automobiles started to come on the road, which led to, by the way, transportation revolution, and so on. And along the way, then the computers came, and computers further led to automation, and that led to basically more advanced robotics and so on. And now we are what we are calling as, in industry 4.0, where we are talking about computers moving to the next level, where they are interconnected, or there are big setups which are called as data centers. We have you know thousands and millions of computers which are kind of doing so much work, and they're handling so much of digital data that is being generated, that is just mind boggling. They are super computer, and that is leading to and like a really powerful change in the way human beings are existing, because the kind of computation that are being done over there were thought to be not possible. And under the hood, if you see, there is whole lot of work which was done for many years in grid computing, which is being implemented in data centers, and which is making these services possible. And we come to know about the services, but we don't know come to about those fundamental things which are implemented from the computer sciences, especially related to grid computing. Okay, now in each of these revolutions, there have been immense, developments related to tooling which have been there. So if you look at it 1.0 era, mechanically driven, things were, very popular. So then came the electrically and electronically controlled. Then came, the computer controlled. And now what we are having is basically more cloud-based, right? And in cloud-based also, we are talking about how we can enable them to make decisions on their own rather than basically having a human intervention, and which has led to the rise of artificial intelligence. Now, the concept of or the algorithms related to artificial intelligence existed before also, but they were not being able to implement it to the extent possible. Number one, because of the data not being available to that large extent. Second, because of the computational power that was needed to kind of process that data. So that has, that kind of a change has enabled AI-based solutions to kind of pick up pace and come to the day-to-day working actually. All right. So if you look at, broadly again, right, as the first the hardware came, then the software, then, we went to the stage of human computer interaction, and then socio-technical requirements, right? That is the kind of emergence of the computing life cycle. And then there is increasing requirement in terms of, information requirements, semantic requirements, community requirements, and so on, right? Now, uh, there was a time where, sending email on a command line prompt itself was a great achievement, right? That would be considered like really prehistoric these days. uh, and the advent of, social networks change the way human communicate with each other. If you look at, WhatsApp or Facebook or LinkedIn and so on and so forth, uh, it has really redefined the relationships between, human to human. Again, the other aspect that you need to look into is that, of course, there was development of computer science, and, the interaction of or the intersection of computer science with business led to development of, e-commerce, web analytics, and then engineering and physics led to, combination of software engineering models and processes, MIS. Then with biology, there was, biotech. Then there is, with psychology, there is the aspects used in bots, creating of bots and sentiment analysis and so on and so forth. So art and design, there is human computer interaction, and, so on and so forth. So there are a lot of streams, right, which are kind of intersecting with the computational things, and newer and newer use cases that are emerging, and how those use cases can be solved or solutions can be created is very, very, interesting, and it is evolving very fast and evolved a lot to that extent, to the extent that we see now. Again, a little bit more on the evolution part. So from, centralized to distributed to internet in 2000, and, the emergence of worldwide technologies, right? Then, kind of explosion of the mobile technologies and usage of mobile, right? And then, like we have this cloud thing which is coming up, and all the computation which is done at the back end at these huge data centers. Now, as I said, um along the way, the computation and the problem solving has gone to the extent that whatever human beings were doing, how we can basically pass it on to the machines, especially where there is kind of a repeat, or there are complex analysis which, need a lot of calculations and are, kind of very difficult to do manually. We can use these, computational machines to do those kind of things, right? And if you look at, as was mentioned, in the earlier introduction, there was this famous Turing test. And by the way, there's a very interesting movie on Alan Turing. Uh, you must watch it. How he basically, developed the machine. So right from those days, right, and when the the in 1955 the term AI was introduced, and development of a bot, Eliza, right, and thereafter there was a long period where, nothing substantial came in the field of AI. But then IBM had been working on this computer called Deep Blue, and they had been trying to implement various algorithms to mimic the human behavior in chess playing, and finally they succeeded in beating the human. And then came, Siri, as we know, right? Watson is very popular again, service from IBM, right? And we see Alexa, which is being used in our houses for all kind of stuff, right? You ask it to play a song, it will play a song. You can order something on, Amazon. You want to hear your weather update, or you want to hear the latest news, right? Those kind of things are there. So on, basically, it has been evolving. Now, I'll take a typical use case, right, to kind of give a more interesting perspective. So let's say, if you look at the customer support or customer service, right, a few decades ago, when there was no, telephone or no email or nothing like that. So how did the customer support happen? The customer support used to happen using letters, right? So for example, let's say if I had to subscribe to a magazine, which was a paper-based magazine, let's say India Today. Uh, so what I will do is, or Business Today. So what I'll do is, I'll take up a form, which is there in the magazine, by the way, and I'll fill it up and maybe attach a, check with it, and then mail it, right? Physical mail, right? And then the acknowledgement will come with the receipt, and then the magazine will start coming to me. Okay, and any communication that I had to do with the customer support of, let's say, this publishing team, I would write a letter and send it. So writing letters was the way basically for the customer service support. Now, with the advent of telephony and its widespread usage, the customer service support moved to telephony. And you could call the subscription department, let's say, and say, I've yet not received my copy of the magazine, and so on and so forth. Okay. And then, as the computers evolved, and user computer evolved, and World Wide Web evolved, and the email came, the customer service started to shift to email, right? And then they went to another extent where they said, you know what, you don't even have to email. On the site itself, we have given customer support service. You can just put your request over there, or put your query, and it will answer that. And now what we see is automated bots. So, which means there will not be even a person sitting behind who's going to look into things and say that, whether it has been dispatched or not, if it is dispatched, where it is, and so on and so forth. And you just type your query, and immediately the chatbot will respond, right? So, for example, you know, even in enterprises, internally chatbots are being used. In fact, in Nagaro, we have a internal bot which is called Ginger, where employees can type in, for example, how many leaves are left, right? So it will promptly say, okay, this is your leave balance, right? Or you want to say, okay, what is the policy for leave encashment, right? So you can just type it over there. Or let's say, what kind of, I want to learn cloud computing AWS certification. So it will say, okay, these are the possible ways we can facilitate you through the organization, and so on, right? So here's an example in the picture that you can see that says, I am Bot's virtual assistant. How can I help you today? So say, could you please help me with the budget planning? Sorry, I didn't get you. Let me get you something that might interest you. Policy 1, 2, and 3. Now, here what he's trying to say is, it may not be able to give you all information, right? But you can build in mechanisms, right, whereby it kind of understand that these are the kind of queries coming, and I don't have answers for that, and people who are managing it then can basically upgrade the bot to kind of start providing that kind of information. Now, if you look at information search again, uh, earlier people used to go to library, right? Look into encyclopedias, look for into journals, and so on and so forth, and then get the information out. But now, with search engines like Google, uh, all the information is digitized, which is digitized, by the way, and a lot of it has been digitized. Uh, Search engines like Google make it easy to kind of basically fetch that information on the click of the button. right? That's the information revolution that has happened. And again, if you look at different people across the world, different languages that they speak, anywhere you go in the world today, you will not feel language as a handicap, so to say, because there are so good translation technologies which are there, and one of them of course is Google Translate, where there are so many languages. In fact, few months back they added around 24 more languages. I think 4 or 5 were from India, and which includes, by the way, Sanskrit also now. So that's quite an interesting development. So earlier, you would have interpreters in a meeting, right, from different if people from different countries are meeting, and they would help to communicate. However, with the emergence of translation technologies, that kind of a thing is being taken over by the technology. Now, it's gone to the next level now, right? The next level is that it's not just the company bots or customer surveys pertaining to a particular product and service. They're saying it could be anything in general, right? So there's very interesting technology which are coming, and I'll talk about it. And Google Lambda, for example, I've shared the transcript over here, right? For example, so I want to say I want to find a good topic for a blog, right? So say, what's a good topic for a new blog? And the bot will say, well, there are so many. How about something about a new food item that you just tried? Now look at the kind of information it is having, right? And it is processing, and then it is giving prompts. So it has somehow figured out that this person is really fond of food, right? And then then the person says, okay, there are a lot of food blogs. How can I make it unique? You can write about a food that you tried somewhere that is exclusive to that location or restaurant. Then it says, sound expensive. Can you give me a low budget food blog idea? He says, well, you could write something about a food that you make on a budget, or maybe something about how to shop for food if you have limited income. Now, if you look at this conversation, it is so human-like, right? And you would see there is thumbs up, thumbs down. Well, thumbs up and thumbs down is a way to make the machine understand whether this response was okay or not okay. And that way, machine learns, right, that the kind of responses this person is looking for, it can fine-tune further based on this feedback, right? And there are a whole lot of basically computation and algorithms running in the background to do that. Now, but before we go into that, the basic fundamental thing over here is that the machine should be able to understand the natural language that we speak, whether it is English or Hindi or French or German or whatever, right? So what is, this understanding by the machine of the natural language? This is popularly termed as natural language processing, or NLP, that term you would have heard, right? So what is it? It is the ability of machines to understand and interpret human language the way it is written or spoken, right? The objective of NLP is to make computer machines as intelligent as human beings in understanding the language. And the ultimate goal is to fill the gap how people communicate natural language and what the computer understand machine language, right? Now, this is very easy to say, by the way. And uh, if you're thinking, it's a kind of it's a kind of a, English to Hindi kind of a conversion, word by word. Even that by the machine, by the way, is not a simple one actually. Why it is not simple? Because machine is a machine. How do we kind of basically facilitate or make it behave or understand, rather than behaving, understand thing like the human beings do? So, for example, let's say a dog is chasing a boy in the playground, right? Now, if you look at it, um, from the grammar, we know there are parts of speech, right? So one of the things that can be done probably, right, by the machines is lexical analysis, which is basically breaking up the sentence into parts of speech. Now, what are these parts of speech? Something is noun, something is, verb, something is, adjective, and so on and so forth. Okay. And from that, you basically do a kind of a syntactic analysis, right? So syntactic analysis is that, what is this person actually, like meaning to say over here, right? And this may be like a person is saying this, maybe reminding other person to get the dog back. Now, is that what it means, right? Or is it just basically observing something and sharing it with the other person? Now, how would basically a machine try to figure that out, right? Um, and then, of course, there's a semantic analysis that, like, for example, the the words which are there, a particular word is occurring how many times and so on and so forth. And the most important thing is, right, with all this analysis, can we basically draw the inference? That is, can we really conclude, right, that, this sentence pertain to somebody, observing and sharing with somebody, or asking somebody to do something, right? So, if we see that when we speak naturally among human beings, there is a lot of common sense or common knowledge which we assume that, the other person, the reader, or, the audience know about it, right? And there are many ambiguities at times, which, we can figure out, but can machine figure it out or not, right? And ambiguity, by the way, is a killer actually in machine learning and understanding, right? uh, so uh, well, I should use a term more like machine understanding, because machine learning is a more technical term, so I will not use that. Okay. Now, so let us see some of the other examples, right? So if you look at, the word design, right? It could be used as a noun or it can be used as a verb. So it's a kind of a, ambiguous thing. Root, right? So, root again can be, used in multiple ways, right? Then there is, in terms of syntactic ambiguation, when we say natural language processing, right? What exactly it means, right? A man saw a boy with a telescope. Now, what exactly is meant over here? Is a man saw the boy with a telescope, or was he seeing the boy using a telescope? Now, how do you kind of interpret this thing, right? Then enough for a resolution. So John persuaded Bill to buy a TV for himself. Now here himself is John or Bill. How do you conclude this, right? Then and presupposition. He has quit smoking. Now, as a human, I would, if somebody comes and tell me he has quit smoking, so I would say, okay, so that means he smoked before. But how do you make machines, understand that, right? So if you look at broadly the natural language processing, there is aspect of phonology, right? The science that helps to deal with the patterns, present in the sound and speeches related to the sound as a physical entity. Then there are pragmatics, the science studies the different usage of language. Then morphology, this science deals with the structure of the words and the systematic relation between them. Then syntax, the science deals with the structure of the sentences. And then semantics, this science deals with the literal meaning of words, phrases, as well as sentences. Okay. Um, Dr. Ritika, just time check. How much time do I have?
Sir, you still have around 10-15 minutes. No
Okay.
issues with that.
All right, let me pace up. And if you look at the whole, the AI cycle itself, how the usage and has been evolving. Uh, you know, Before 1960s, they were very simple, logistic or linear regression, algorithms that were being used. And then, in machine learning, well, you can use these machine these algorithm machine learning also, but then they started to advance, right, to more complex kind of algorithms, right? Then they went into deep learning. So it's that you were doing repetitive tasks, and you started to imitate, then you started to learn from the imitation, which was deep learning. Then from the learning, you derive learning, right? So that was deep reinforced learning. And then you started to contribute and exchange, like we are saying in Lambda, right? Which is kind of really uh, too deep actually, right? And if you look at the evolution of the NLP models, right? Starting with what I shared with you, bag of words, kind of an example for the dog example that I shared with you, right? And going all the way, right, to various kind of basically models which have been coming along, transformer models have been really breakthrough technology, right? Now, why it has been a breakthrough technology, I'll come to that. If you look at machine translation again, we had simple rule-based translation. Then, we started to do statistical analysis to do more, better translation. And then, we started to use neural networks, right, for doing machine translation. And if you look at, the sentence which I shared in the beginning of the presentation, where, this was about Federer, on his retirement, right? If you look at the highlighted words over here, Federer, he, his, when we read this sentence, we can clearly make out that, this is being referred to Federer, right? But what about machines? How do we make it understand the way humans do, right? That is the kind of challenge that we are facing. So capturing such relationships and sequence of word in the sentences is very important for the machines to understand the natural language, right? And transformer is one of the technologies that helps in doing this, right? Now, if you look at this, most of this data and in the text that I shared with you, it's a text sequence, right? Similarly, we have other data like a number sequence or a video frame sequence or an audio sequence and so on, right? In real life. So for example, a movie or a YouTube video, for example, is nothing but a sequence of frames, right? Or, financial numbers, right, are nothing but, sequence of numbers, right? Any data, if you see, numerical data is a sequence of numbers, right? And, all the text that we, write or speak and convert to text is again basically sequence of text. And so in NLP, we need models which can basically convert type A to type B. For example, in machine in case of translation, we want to convert, let's say, from English to German sentences, right? And it's a sequence to sequence task, right? And one of the popular way was to use the recurrent neural networks, RNN, right? They were very popular till the transformers came. Now, just kind of give you a idea about what RNN is. We'll take a simple example. Let's say the English is please come here, and the German is come with her, right? So if you look at how it works is that these are these words that are going. They have some hidden context. Each encoder kind of generates an output, and this is basically given to the decoders, and from one decoder to the other it passed on. So it's a kind of a sequential processing where based on the previous state of such data that was handled, right, the output from the encoders is generated and it is fed to the decoders, which basically then generate the outcome, which is the translated text. So we started with come with her, right, and then it basically says please come here, right? And this is the kind of process that happens in a simplistic terms using a RNN based sequence to sequence model, right? So I will not go into the technicalities of it, right, in the interest of time, but I'll share the slide deck. You can go through that. Now, so what is the advantage, disadvantage of using RNN? And then, like, what are the kind of things which are done in transformer which basically overcome this disadvantage? Now, typically, if you look at it, the neural network is, you have different layers of processing the data, right? Where based on the feature set that you selected, you give that as an input, right? And that is processed, right? And fed to the next layer, then it further processes and refines it, goes to the next one. So based on the number of features that you have and the number of layers of computation that you have, you kind of refine the output that you want to generate. So for example, let's say if I were to feed a let's say a German sentence and convert it into English, right? The various parameters about the sentence that I've been able to capture based on the previous learning of let's say huge data set of the converted sentences, and then what new sentences come in, I basically try to use this algorithm to find the right or construct the right match for the translated sentence, right? Or let's say if I have a a data set of various images for animals, right? And if I give it a picture, any random picture, then through these layers, it basically gets further refined to exactly what would be the right match. Now, doing basically a kind of a match pixel by pixel of a given image with let's say billion of images is a humongous task, right? But we need a more intelligent and faster way, and that's where basically the neural networks come in and help us by way of giving these artificial intelligence to kind of rapidly zero down to the exact matching one, which or the nearest matching one which would be there, right? All right. So so I'll skip this part. So in terms of basically learning process, when an input is given to the neural network, it returns an output. On the first try, it can get the right output by its own, right? And that is why during learning phase, every input comes with its label, explaining what output the neural network should have guessed. If the choice is good one, actual parameters are kept and the next input is given. However, if the obtained output doesn't match the label, weights are changed. Weights are basically, when we process this, the various features are, given various weights. So I'm not going to the mathematics of it because that will get complex. But broadly, what you can see is through these different layers, the filtering is being done, which help us to kind of get to the exact output that we are looking for. So as I was sharing the example, if I give, let's say, two pictures to it of that type of cat and a dog, and then through the algorithms which have kind of matured by way of the training data that I gave to it, it should be able to predict, right, whether which one is cat and which one is dog. Okay, because that is very important. If I have, a robot, let's say, which is going around and it figures out, some stranger, then it should be able to know that this is a stranger and not open up the door for it, let's say, if it is a household robot. Okay, now there are different kind of neural networks. I will not go into it, but most important is the feed forward neural networks is from one layer to the next layer, the information is passed. But in recurrent neural network, the feedback from each layer is passed to the previous one, right? So that it kind of improves over a period of time further, right? The advantage of the recurrent neural network is that that each and every information through time is preserved, right? And if it is a, let's say, a time series prediction, they are very they perform very well, right? But the disadvantage is that training RNN is very difficult. It needs, because it's sequential, it takes long time to process, so it's not very efficient, right? And that also basically prevents it even bringing parallelization. So so all in all, they are good, but if you have to scale up a solution, right, which is needed in a kind of a live conversation, and if you have to train the model on huge data set, then it becomes not really that useful actually. So that's where basically the transformer technology comes in, right? It's a novel architecture which aims to solve the sequence task while handling the wrong range dependencies with which the RNN cannot handle, right? Now, so there's a very interesting paper which was published by Google Brain team, which is said attention is all you need, right? So I will just bring up my thing here. So this is, on the Arxiv site, right? And here you will see the all you need. It has all the details. But anyways, I'll skip the detail part and come to the core part of it. So core part of it is basically transform is the first transduction model relying entirely on self-attention to compute representation of its input and output without using sequence-aligned RNNs or convolutions, right? So what exactly it is? So basically what it does is that it kind of basically whenever it is processing the data, right? So before I go to how it processes the data, let me just give you a little brief about the how the the concept of yeah. So every time basically we were processing the data from this neural network, right? Um, the state was kind of stored, right? But as we said, that was kind of not very effective, and there was no parallelization that was happened. But in case of the uh, in case of the transformer, what we have is that we have this kind of an architecture where we have the encoders and the decoders, but these encoders are really sophisticated. So they have a concept called multi-head attention, right? Now, what multi-head attention does is, in brief, is that the each and every word that is coming, right? What is the kind of attention that needs to be given to it, right? And there is a kind of a complex mathematics, right, related to how that attention is calculated. And I'll just give you a brief idea about it. If you see, the calculation of the self attention is based on three things, right? Which is basically the query vector, the key vector, and the value vector, right? Now, uh, again, basically, let's say, for example, the word sequence is action gets results, right? So, based on the key vector and the value vectors, you compute the scores, right? Which is a dot product of these. And then basically with these dot products, right, you kind of divide it by the square root of the dimension of the key vector, right? And then move on to basically applying the softmax function, right, which generates basically your outcome of all these dot products. And based on these outputs, you further kind of basically use the value vector, data dot product, and sum it up, right? That generates the sum. And this basically gives you the net outcome actually, right? Now it's a more complex mathematics which is there, so I'll skip that part. But the idea is over here that this kind of a analysis which is done at the encoder level and at the decoder level results in very good kind of analysis of various natural language processing that is being done, whether it is in terms of translation or other use cases which are there. So this is more detailed actually, that from one encoder, then they have you can have multiple layers of encoding, right, which kind of further fine tunes it, and then you can parallel process it to send it to multiple decoders, right, which kind of further refines the output that is being generated, right? So again, briefly, the concept of self-attention which is being used, it is also sometimes called intra-attention, is an attention mechanism relating different position of a single sequence in order to compute a representation of the sequence. So for example, let's say the sentence is, the animal didn't cross the street because it was too wide, right? Now, what if you look at this sentence, right? Can you figure out what the term it in this sentence refer to? So whether it is referring to the street or to the animal, right? So it's a simple question for us, but based on the normal usage or the way we kind of use the language, we will interpret it. But for the machine, right, it is not that simple actually, right? When the model is processing it, self attention try to associate it with animal in the same sentence, and that is based on the huge data set on which it is kind of trained, right? And when sentences like this come, and it is able to relate to that kind of a machine learning which has taken place and interpret it accordingly, right? So this power of basically understanding these kind of combination of things, right, and be more accurate with it, with the kind of the context of discussion, is where basically this transformer kind of a technology is very powerful, right? Okay, I'll skip these. So various basically applications where this kind of a technology is being used is machine translation, document summarization, document generation, right, and so on and so forth. So if you look at machine translation, Google translation is a very good example. and they have been getting accurate day over day over day, right? Document summarization. So these tools have started to come in mainstream in, for example, we are seeing it in MS Office products and so on, where if you have a given a big document, you can summarize automatically using these technologies, right? Even document generation, right? So now there are basically bots which are kind of enabling to generate stories on their own, right? You just have to give them some themes and some pointers, right? Biological sequence analysis, right? If you have heard about a venture called AlphaFold, right, where basically they do molecule sequencing, and which was which has been acquired, I'm not sure whether acquired or funded, but a lot of money has been poured from companies like Microsoft and so on, right? So let us now look at quickly the various offerings. Okay, so one of the most famous offering which has been going around is from an organization called OpenAI, right? And they have these transformer technologies which they have matured, right, and advanced over a period of time, which they call it as GPT-3. GPT, generative pre-trained transformers, and they release version 1, 2, and 3. So the latest is 3. Just a background, it was basically started by founded in San Francisco in 2015 by Elon Musk of SpaceX and Tesla, as you had heard, and Sam Altman and others, who collectively pledged around 1 billion. Musk later on, he moved out, but he remained a donor. And in 2019, OpenAIP received 1 billion investment from Microsoft also, right? And it has licensed some of its technology. So the transformer technologies that they've developed, version 1, 2, and 3, if you look at the parameters, right, that they can process, right, for a given use case, right? So for example, let's say you want to do the analysis of the images, right? Or you want to do the analysis of, let's say, predicting the stock price of a given stock, right? Or basically, let's say from the images of a cataract patient, kind of predicting what kind of a cataract it, or what kind of complexity over the years it can have. You can process that with a couple of features, or hundreds and millions of features. So the kind of parameter support which is there in GPT, starting with 117 million, it is around 175 billion actually. So you can imagine the kind of parameters that you can process, right? And that could lead to so much accuracy in your predictions, right? Decoder, we have around 96 decoders, and so the other details are there. I'll skip that. Um, Moving on. So one of the most interesting use cases which is there, and which has been getting a lot of attention these days, is from this transformer technology from OpenAI, is DALI, right? It's a new AI system that can create realistic images and art from description in natural language. So what it means is that if I say something to it, like in the beginning what I said about the kids playing in the background of the Golden Gate Bridge, you can generate those kind of images. So if I, let's say, go back and look at that, yeah, over here, right? So let me just copy paste this. And by the way, all of you can sign up on this page at OpenAI site on DALI, right? And you can, if you go over here, right, there would be a somewhere sign up, so you can sign up actually, I think. This is the sign up page, and I have signed up already. So if I, let's say, put this sentence over here, right, and say generate, okay. So see, this is a painting of a fox in the style of a starry night. Now it is basically interpreting, all this text, right, and all the textual information has been basically processed with a huge data set of images, right, where then it can basically break up the context of the sentence and pick up fragments of different images, right, and what needs to be constructed based on the understanding of this intent, and that comes up. Now this is really amazing actually, that it has been able to interpret this sentence completely and generate something almost from a scratch, right? That is the power of basically, the transformer technologies. Now, look at the use case of basically, let's say, an advertising person, right? A creative designer, right? If a theme is being discussed about creating an ad campaign for a product, uh, he doesn't have to go back to his editing tools like Photoshop and so on, and then spend time and creating that and doing that hard work of basically adjusting colors and so on and so forth and coming up with the first draft. Now, first draft now creation would be as easy as basically writing the sentence, right, and the whole image comes up, and then he can basically go and edit those. Not only this, he can edit. That feature is also coming up over here, but it can generate variations also, right? So based on if I like something particular image, I can generate variations out of it, right? And this is going to so the all the kind of hard work which was not very creative but kind of a manual in creative people's life, that can be now taken care by the machines. Okay, this is one such example. If I so can you just type on chat window anything that you want to create? Anybody? Let's try that out. Anything? Or anybody can speak out if they want to try out something. So let's say it's a sunny Durga Puja day. So let's say a school playground. I'll try that out. So if you can see this, this was a see. So it's come in the open, it's bright, right? And it's created those kind of a variation. So somebody asked for a school playground, right? If I do this, see, these are not kind of a stock photos which are which a lot of by the way stock photo platforms offer. This is a uniquely generated kind of a thing, right? So here it is actually a playground. Now you can do modifications to it. So this is one very interesting use case of the transformer technologies, apart from basically, what I told you about, in NLP and so on, right? Sorry, in translation and so on. Other one is basically, I'll skip this whisper. You can check it out. Other interesting one is Copilot, right? So let me quickly show you that, okay, in the interest of time. So I think I already have it open. Okay, so OpenAI Codex basically is another usage of these transformer technologies where their systems translate the natural language to code. Now, what exactly that means? So people who are kind of into coding, right? If I just scroll down over here, right, um, it has got very interesting use cases. Just I don't know, it's conflicting with that. Okay, so based on the Codex technology, we have a tool called Copilot, which is available with GitHub. So if you can see over here, right, determine whether the sentiment of the text is positive, use a web service, right? I just write that comment and it generates the whole code for me. Okay, right? I don't have to kind of I don't even have to know where the let's say the sentiment analysis API is available. It can even find that out, right? Or let's say if I say get average runtime of successful runs in seconds, it will immediately write the whole code, right? And so on and so forth. So there are many interesting usage of this thing, and it will enhance the productivity of the developers quite a lot, right? Moving on. So there are various offerings from OpenAI. Whisper is kind of generating text from speech, right? Clips is the reverse. You give it an image and it will generate a text describing that image, right? And so on and so forth. Okay, so I'll skip these. Next, I'll quickly spend 5 minutes on two interesting transform-based technologies. One is Lambda, another is Palm. right? So what is a Lambda? So Lambda, again, there is a paper which is link is here, but I'll not go through it right now. Lambda is a family of transformer-based natural language models specialized for dialogue, which have up to 137 billion parameters and are pre-trained on 1.56 teraflop words for terabytes of words for public dialogue data and web text, right? Now, it's a very interesting. I don't know if I'll be able to play the video or not, but let me just try if you can hear the video part. How do I get rid of this? Can you hear the audio?
No, we can't, Ganesh.
No, sir.
Okay, okay, no problem. So I'll just describe, right? So basically, it's a very interesting concept where what we okay, let me go back to there. So basically this demo is kind of talking about how this conversation works, right? That this conversation which I showed you in the beginning, right, is where the whole lot of this basically text which is being typed by the person. For example, what's a good topic for a new blog, right? Now, this is being, first of all, the natural language processing is being done, but at the same time, the effective transformer technology, which kind of processes it, figures out, right, what is the response should be for this, and then constructs that response. So this is, so one use case was the translation. Another is, for example, the image that we generated. Now here, basically, it is a question and answer use case, right? That I am asking a question to the machine, right? And based on the training that has been given to this using lots of data, which they talked about 150, 1.56 terabytes T of data, and the parameters which are used to process it around billions of parameters. It is basically kind of processing and giving the response, right? So when it asks what's a good topic for a new blog, well, there are so many. How about something about a new food item that you just tried, right? So this response generation is based on this, the technology that they developed, right, which is again transformer based. It's called Lambda, right? Now, there could be many interesting use cases for this. So, for example, you want to, start a new kind of, you want to basically have, let's say, find about a hobby that you want to pursue, right? Or you want to find about, let's say, quantum computing, right? So you have various queries about quantum computing. So currently what you will do is, right, that you will go and search for information and then try to develop your understanding. But here you will kind of go and ask the questions, right, and it will keep on giving you responses, right, and that will kind of further clarify your concepts related to quantum computing, right? Or let's say you want to find out about legalities of a certain thing. For example, let's say you want to find the legalities of purchasing a property, right? So it will give you information about that and so on, right? Another interesting technology is Palm, right? Which again is basically, it has 540 billion parameters on which it processes the data, and it has, very interesting use cases, right? So some of the use cases I want to show you, yeah, over here. So if you see, it has been growing over the years, and they have really, added a lot of, capabilities to it, right? So as you can see. Uh, but more interestingly, so cause and effect. So for example, which of the sentences makes more sense? I studied hard because I got an A on the test. I got an A because I studied hard. So model will basically kind of respond to that. What movie does this emoji describe? It can answer that, right? Or let's say, based on, for example, Roger has 5 tennis ball. He buys 2 more cans of tennis ball. Each can has 3 tennis ball. How many tennis ball does he have now? Right? And it can, from this textual information, do the calculation and give it. But the good, one of the interesting aspects of this is that you can explain to the model if it gives a wrong answer, that what is the right way to get the right answer, and it will use that information to process the data further, right? And also use that kind of a thing in other kind of analysis, right? It can explain a joke, right? So for example, if you give it a joke, did you see the Google just hired an eloquent whale for their TPU team? It showed them how to communicate between two different pods. So it's a TPU is a type of computer chip that Google uses for deep learning. Pod is a group of TPU. A pod is also, so like all those kind of things actually. And lastly, I like to conclude that when you basically put this technology, right, onto robots, right, that these robots basically become real life kind of humanoid, right, and you can basically communicate with them in various ways. So Palm Secan is one of the robots which has been co-developed by Google, where for example, if say I spilled my drink, can you help, right? So it will go to the kitchen and get a mop and do it. By the way, this is not hard coded. So by observation, right, it will learn that, for example, which mop to use for cleaning the floor, which mop to use to clean the table, right, and so on and so forth. Okay. uh, and then coming back to basically just a funny side, if you have watched the movie Transformers, right, there's a character called Optimus Prime in that. And since audio is not available, so it will not be that interesting, but still kind of I'll play it for you. So if you see in this movie, right, there are these Transformers, right, and there is this, and this is autonomous robotic organisms, as they call themselves, and this was their lead called Optimus Prime. And there's another Optimus Prime that has been launched, not Optimus Prime, just Optimus, yesterday, right, by Elon Musk. And this robot is also called Optimus, and here is a view of that. Sorry, I should not have gone full screen. It started to buffer.
So Ganesh, sorry, just a quick time check actually.
Right. I'm finished. So can you see the video?
Yeah, we
Yes,
can.
sir.
So this is the Optimus robot, which was launched by Elon Musk at the Tesla AI Day yesterday. And as you can see, it has locomotion capabilities. And when you plant or you basically embed all the transformer technology on this robot, right, it will be able to process whatever we are saying in a very, very human-like way. So so we are actually moving towards a stage where machines would be more like humans in times to come. All right, I'll stop here. Thank you so much. And, I think I took more than what was allocated to me, but hope it was of value to you. Thank you.
Thank you so much, sir. It was a very informative and a very interesting session, which the participants have taken equal participation in. So I have a number of questions. So with
Sure.
your permissions, should I take up the questions?
Sure, please.
Yes, sir. So the first question, how do these transformer technologies impact us in our day-to-day lives? If you could please give some examples.
Right. So I think if you look at the Google search, right? The way it basically refines the search now, right, is based on the kind of queries that you have been doing and the various parameters about you that it captures, right? So if you have not opted out of Google capturing your information, so for example, all the email exchanges that happen over the Gmail, right, it gathers a lot of information about that, right, about you. And next time when you basically do a Google search, right, or your browsing history, for example, right, so it kind of profiles you on various parameters. So what those parameters could be, your age, your gender, your hobbies, right? If you're using Google Maps, it will also know what kind of restaurants you have gone to, right? So next time, and with these parameters about one person, right? When it processes that with, so many other parameters related to that restaurant, or to the kind of photographs that you are taken and share on Google Photos, right? There are, hundred millions and billions of parameters which it processes the information, and the search result that it gives to you, they try to make it better and better, right? That is one example of it. um, yeah, but it's evolving. There are lot many things that are going to come in future, which will use these kind of transformative technologies.
Absolutely, sir. Rightly said. The second question I have, can a transformer be used for classification problems as well? And I would like to add to this that what are the problems where a transformer cannot be used as such?
Yeah, so it's basically, this technology is fine-tuned towards a natural language processing, right? There are basically, general transformers, right? Where you just not use it for natural language, but for other use cases also, right? But personally, I have not studied that much, but there is, work going on, right? Where, for example, as I shared with you in molecular research, right? There is a lot of basically usage of transformer technology which is taking place. Um, so coming back to your question, what was the question? Sorry, I missed the part.
Uh, what are the areas where transformer technology, or what are the problems where transformer
Right.
technologies at the moment?
Right. So as I shared in the presentation also, so for example, search or the conversation bots which are there, right? Or molecular research which is there, translation, right? All these are the places where these transformer technologies are being used.
Okay. So next question we have. Once Elon Musk had said that I want Neuralink chips to help humans achieve a symbiosis with artificial intelligence. Isn't it going to change the natural laws of human evolution?
I I don't know what the natural laws of human evolution are, right? So first we have to develop an understanding of that, because I think we we don't even have a complete understanding of how the human body operates right now. There are so many gray areas. So, for example, we don't have full understanding of basically how the brain operates, right? Completely, right? But having said that, uh, you see, it's an ever evolving situation, right? And if I basically take you back to the beginning of my slide, right, where the humans didn't exist on this planet, right? And the dinosaurs existed, and the dinosaurs became extinct, not because of some natural thing. It was most of it was basically by asteroid colliding with the earth, and destruction of the vegetation on the planet, which made basically the big dinosaurs to not survive, especially the plant eating ones, and the flesh eating ones survived on the plant eating ones, right? And when the high vegetation was not there because of the hitting of the asteroid, so the low vegetation, they could not bend and eat it, right? So they got extinct, and there were many species of the human beings, right? So you would have heard about, for example, Neanderthals and so on and so forth. But as a natural evolution, or unnatural evolution, I don't know, they fought among themselves. That's again a question. The Homo sapiens survived, right? And the current human beings which are there are the Homo sapiens. Now, Homo sapiens also over the years have evolved, right? So, for example, we don't do cultivation anymore, right? In fact, cultivation itself was not done by the human species. They would just roam around in jungles, right? Eat food, or kill animals and feed on them, right? And then the concept of cultivation started, right? Then the concept of basically industry started, right? And now many people, we don't go and grow food, right? Somebody else grows it, and we pay it. So we have been evolving, and I think evolution is the natural behavior of the human beings. So I I'm not sure what the natural evolution is, but whatever is happening is a natural thing for the humans, because the way their cognitive uh, behavior is actually, or capabilities.
Absolutely, sir. Very rightly said. And once again, a very big thank you for this wonderful session today. I will now request Professor M.N. Hoda, sir, Director, Bharati Vidyapeeth Institute of Computer Applications and Management, to present Ganesh, sir, with this small certificate.
Thank you so much, Mr. Ganesh. The topic which you are talking is an ever evolving topic, and we do not know where it is going to land, because every coming day the natural intelligence will increase. Every passing day, the people will acquire more and more knowledge, more and more innovations, and that will keep on putting challenges before the AI, and that AI has to map to that changing need of the knowledge base of the human being. So it is an ever evolving topic, and this 1 hour is not sufficient to discuss this. But yes, you have introduced nicely that to which extent it is going to create an effect, and that is a positive one, and to which extent it is going to ease out our life and make us to understand that creativity, the human and natural intelligence can be used for many other constructive purposes if we could save time out of this. So thank you so much. I'm sure in future we are again going to meet for some another session, technical session on some another topic. And this certificate is not for the purpose of certification, rather for the purpose of just remembrance that you have been part of this lovely webinar, which was attended by over 400 people from across the country and abroad, including this WebEx room as well as the live streaming on the YouTube. So thank you